Hey everyone, Shashank this side, currently working as a senior data engineer at Expedia and previously worked for one of the FAANG company like Amazon. So in today's video, I will give you a complete roadmap to become a data engineer at FAANG. So before starting our main discussion related to data engineering roadmap, if you are new to our channel, make sure to hit the subscribe button and press the bell icon. Alright, so the first thing which is really important to start your journey in the data engineering, that is programming languages. So I have seen lots of people talk about this thing that for the data related profiles, programming is not needed at all. So I would say this is completely wrong because the data engineering is a kind of job profile where lots of engineering work is actually required. Like you will be creating data pipelines, you will be writing custom codes. So that's why understanding of any of one programming languages is really important. So what kind of languages you can prefer in the data engineering domain? So there are three languages which are really popular. First is Python, second is Java, and third is Scala. So now you might be thinking which one should be preferred. So if you want to take my opinion, I would definitely recommend the Python, and there is a solid reason behind it because under the umbrella of big data, there are multiple job profiles including data engineering, data analyst, data scientist, machine learning engineer, and mostly they are using this Python languages because Python language has a strong support for multiple data manipulation libraries. That is the prime reason. So let's say after 4 or 5 years you want to move from data engineering to data scientist, AI ML related thing, then it would be really easy for you if you have started your journey with Python itself. Now for the college students, I know like you might be working on languages C, C++, right? But still you want to make your career into the data engineering, you want to start with that, then like at this moment you need to switch your target from C, C++ to Python, Java and Scala, and that would be my recommendation. Okay, so now coming to the second important point, let's say you started with the Python programming. So because your work is actually related to data manipulation, so definitely there should be some libraries and you should have a good hands-on on that part as well. So in Python there are three very popular libraries. First is pandas, second is numpy, and third is matplotlib. So when you start with the Python programming, so after learning all the basics, let's say if else, looping, variables and multiple other things and its prime data structures, then your target should be to focus on these libraries. Like you can get some dummy data and try to manipulate it with the help of these libraries because the pandas and numpy are mainly created for that one, where you can process your data, you can just do some operations like joins, group by, and you can do the data exploration part. Similarly, the matplotlib is basically for the visualization. You can create some basic kind of graphs like line chart or pie chart or bar chart. These kind of things you can do with the help of matplotlib library. All right, so coming to the third part, and that is the operating system and the scripting part. So I'm pretty sure in your college time, if you are coming from the CS background or somehow let's say non-CS, then at least you would have listened these terms like Linux, Unix, and these kind of operating systems. So mainly when you work in the IT industry and a full-fledged production level application, be it anything, let's say web application or any like data engineering related pipelines. So ultimately what will be happening, you will be operating on these servers, right? And we know there is a GUI as well, like which is in our laptop where you can point onto different files with the help of mouse and anything, right? And you don't need to write any commands specific to any operation. But that is not the case with these Linux and Unix based machine. Whatever you want to perform, even if you want to copy a single file from one source to other destination, you definitely need to write a one command. So that's the thing which is happening in the data engineering as well. Mostly whatever data you will be getting, that might come from different servers. For an example, FTP, SFTP, right? So these kind of servers will be there, and let's say your clients are dropping the files, the input files on that server particular location, and from there you are trying to consume that data and then trying to process it. So you should be having a really good understanding of how to operate on Linux, like the basic commands, how to look for different files, copy, moving, and how to even extract the data, multiple other amazing things to automate the things as well. Like if you are trying to transfer files from one location to another location on time to time basis, right? You can write the cron jobs, which will be a kind of scheduled job in your application, which is doing this file movement. And similarly, the shell scripting part is also very, very much important. So when we talk about these Linux and Unix based machine, they understand this part as well, like shell scripting, whatever you want to perform, let's say multiple operations together within a one single program, then you can write those commands in one single script, and that is basically known as shell scripting. It has its own way of executing the things, and it has its own syntax. So you should definitely learn it, because that would be really, really helpful when you will be automating your data pipelines. Okay, so now the next point, which is really, really important, understanding of data structures and algorithm. And honestly speaking, there are some myths about it as well, and I will try to burst those myths. But before that, I will talk about how much data structures and algorithm actually required in this data engineering domain, and even to crack your interviews, plus what all topics you need to majorly focus on. And again, whatever I'm explaining, completely based on my interview experiences, because I have appeared in multiple interviews for different product-based companies, including Google, Facebook, Uber, Amazon, Microsoft, many more. So based on that experience, I'm going to tell you what all topics you actually need to focus. So the thing which is important in the data engineering from the interviews perspective, the arrays, strings, linked list, stack, queue. Dynamic programming is something which is also very, very much important, but you don't need to jump onto the hard level of the dynamic programming or the tough part of that. And similarly, there will be questions related to tree and graphs, and mostly it will be on very, very basic levels, like they can ask the traversal related thing, or any like algorithm which is existing, so they can ask questions related to that, but they won't be jumping onto the hardest level of the trees and graphs as well. Now the myth which I am going to burst here, that you need to be a like pro coder, or let's say you need to be have a really good experience in the competitive programming in order to crack the DSA related rounds for data engineering domain. So that is completely wrong. So based on my experience, this is the thing I have observed for the data engineering related profile. Only you need to focus on the DSA part till the medium level, not more than that, like easy medium till medium level. Beyond that, those companies won't be asking any question, because data engineering is more about your skills for the big data processing. So in the interviews, there will be multiple technical rounds where they will focus on your designing skills for the pipeline, not like again and again judging you on the DSA or hard level of DSA questions. So don't worry about that one. If you are someone who's having an average understanding of this DSA part, then the data engineering profile is good fit for you. So now coming to the next point, which is understanding of database management system. So this is the subject in your graduations as well, right? In your graduation, you would have read about the databases, database management system. So in the data engineering role, right, your day-to-day activities will revolve around these things, right? The databases, the tables, querying the data, these things. So you should have a really, really good understanding of the important things in the DBMS, like what is the transaction, what is the concurrency, the ER diagrams, the different kind of indexings, hashings, right? And multiple important concepts related to the DBMS. Definitely you need to focus on it. Sometimes these concepts will be like very much important from the interview perspective as well, because interviewers will indirectly ask you these questions where they can ask like, can you optimize this query performance, right? So in that case, if you don't have these understanding like how databases works under the like hood, then in that case you won't be able to clear those rounds, because you cannot pinpoint those particular optimization techniques. So that's why DBMS part is very, very much important. Now coming to the SQL part. So SQL is something which is definitely really, really important, and from the interview perspective, SQL will hold at least 30 to 35% of weightage. And in data engineering, not only data engineering, because we have multiple job profiles as well, like the data science, data analyst, and business analyst. So Our roles and responsibilities will be more towards on the data representation as well, querying it in a proper manner and just pulling out those meaningful insights from the data. And that's the point where SQL will be really helpful. So it doesn't matter if you are a fresher or the experienced candidate, the expectation for the SQL from the interviews would be really, really high. So you have to be really good at it, not the basic part of the SQL, like medium level of SQL as well, plus the advanced things which are available in SQL for querying, that would be also needed for your interviews and for your day-to-day activities as well. So in SQL, what all things you majorly need to focus on from the data querying perspective, like the simple table creation operation, select operation, how to apply the where clauses, ordering of data, and then comes the group bys and multiple type of joins are there, how to write the subqueries, common table expression like with clause, and case when operation with group bys, and most important is the window functions in SQL, because these are something, let's say you are going into the interviews, then you should definitely expect at least 1 to 2 questions which will be related to the window functions. So that's why I'm saying SQL is really important. Okay, so far whatever I have talked about, that was actually your building blocks, right? Without understanding of the programming, DSAs and everything, you cannot even move into the data engineering part. But to become the actual data engineer, the core understanding of big data is definitely very important. But I won't tell you that you should directly jump onto this framework and that framework. I would ask you to start your journey with the basics as well. First, you need to understand the terminologies. What are the important big data related terminologies? For an example, like what are the 5 V's of the big data? There are different file formats available in the big data, or whenever we process the files or the incoming source data. So popular file formats like the JSON, CSV, Avro, Parquet, and similarly there are different types of data as well. Like sometimes it can be unstructured, sometimes it can be structured and semi-structured, right? So you need to understand these basic terminologies, and most important, how this distributed computation work, what is commodity hardware, what is the cluster, right? And how this distributed storage works, what kind of frameworks available for that. So that understanding is very much important, because without that you won't even able to understand any important framework which is available in the big data. So that's why please focus on the terminologies first and then jump onto the advanced part. The next part is the understanding of data warehousing. So data warehousing, people who don't know about it, that is something where we will be keeping our transform data for the analysis part, right? So data warehousing also have its own concept, like how to store the normalized and denormalized data in a specific form, and how multiple tables should be connected with each other, what should be the proper relationship with them, and what is the OLAP, what is the OLTP, what is the fact table, what is the dimension table, what is the difference between star schema and snowflake schema. So these are the some important things which are available in the data warehousing concepts. And I do remember my interview experiences where interviewers were directly asking these questions, like, can you design the data warehouse for food delivery application? Can you design a data warehouse for the ride applications like Uber and Ola? So these kind of questions will be there in front of you in your designing round and data modeling round. So please focus on the data warehousing as well. Okay, so now coming to the most important part, the understanding of important big data related frameworks. So previously we covered the terminologies part, and now I will pinpoint what are important big data related frameworks are available in the industry and what all things you need to cover in that particular framework. So first, to start with the base part, that is the Hadoop. Hadoop is something which is really important, and you need to deep dive into it. For the framework perspective, you need to understand its architecture, how Hadoop actually works, what are its important components, so that when you will appear in the interviews during your design rounds, where interviewers will ask you questions related to pipeline designing, and they can ask you that what kind of framework you will be using. So if you don't have the clear-cut understanding of these kind of frameworks and what are their architectures, then you won't be able to answer those questions, right? So now the big question is what all things to cover in the Hadoop. So there are 3 main components of Hadoop. First is the HDFS, second is the MapReduce, and third is the resource manager, which is Yarn, right? And I know Hadoop is something which is a old school technology, but it is definitely the base for all the frameworks which are built on top of it. So in the Hadoop part, we don't need to focus on MapReduce coding, but we need to understand the MapReduce functionalities, because this is something which has been inherited and being used as the main concept of distributed computation. So focus on HDFS, understand the working and functionalities of MapReduce, and how these resource managers like Yarn work together for the job scheduling, resource allocation, and these aspects. Now talking about the most demanded framework for the data engineers, that is Apache Spark. So Apache Spark is something which is definitely 100 times faster than Hadoop, and a very good fit framework for the batch data processing and real-time data processing as well. That's why Spark is something which will be treated as your core skill if you are moving into data engineering. And in interviews, right, there will be multiple questions related to it, right? And why? Because Spark is something which is really important, first of all. And second thing, it's different component. So there are three main components of Apache Spark. First is the Spark core, second is the Spark streaming, and third is the Spark SQL. So why it becomes very much important? So let's say you are a core programmer, you know how to code the things, writing the custom code using Python, Java, and Scala. Then definitely you can use the Spark core functionalities like its inbuilt libraries, method, and you can code the thing. But Spark comes with a very amazing thing, an amazing component named as Spark SQL. So if you are someone who don't have any understanding related to the programming and all, and you know SQL, right? So whatever logic you want to implement, you can write it in the form of SQL, and you can just use those Spark SQL methods and compute your things. So that's why Apache Spark is very much important. Now coming to the third important framework in the big data, that is Apache Hive. So Apache Hive is basically a kind of data warehousing service, and that is also very widely used by different companies for their analytical reporting. So there are multiple concepts in Hive like the partitioning, bucketing, how to load the data in the Hive tables, internal tables, external tables, concept of views, right? So these are the things which you actually need to cover in the Hive. And there are multiple other frameworks as well. So based on different use cases, you can identify, you can do some POCs and try to figure out which framework is good fit for use case. And let's say you want to do a pure real-time data streaming, and you want to create pipelines which are completely depend on the real-time data, then you can explore Apache Flink as well. That is the tool which is really growing, and in my current organization, we are using this tool as well for the real-time data processing. Okay, so the next thing is the schedulers or workflow managers. And what are these things? So let's say you have created your data pipelines where you were using multiple sources and you were consuming data from there, and then you had, let's say, Apache Spark or Hadoop in between, you process something and then dump data into the downstream system, right? So these pipelines are sometimes like manually operated, and there can be multiple data pipelines which are somehow interdependent on each other. So definitely we should have some frameworks or kind of workflow managers which can manage these pipelines with pure dependencies and the data backfilling operations, these things. So in the data engineering, or you can say the big data world, there are 2-3 workflow managers or schedulers which are really popular. First is Apache Airflow, second is the Azkaban, and third is Apache NiFi. So these are the top 3, or you can say the popular schedulers which are in the industry. So you can focus on that. Now talking about the next thing, which is understanding of NoSQL databases. So NoSQL is something which is very much important into this big data domain. Why? Because we cannot handle the data or like whatever volume we will be operating in the big data world with the traditional databases like MySQL or Postgres. And in order to get that partition tolerance or high availability or consistency, we will be needing those kind of databases which are not only SQL but kind of NoSQL databases. So there are multiple available NoSQL databases based on different use cases and based on the CAP theorem as well. So why I am taking this name CAP theorem, so that you can explore it, why we talk about it, and how it can be really beneficial to figure out which NoSQL database is good fit for our use case. So if we talk about the important databases, like the Cassandra, Elasticsearch, HBase, MongoDB. These are the well-known and very, very popular NoSQL databases. Okay, so the third last thing is the messaging queues. So if you remember when I was talking about the real-time data streaming pipelines with the help of Spark or the Apache Flink. So whenever we will be working in the real-time world or the real-time data streaming, so from the source end, we should have some mechanism or we should have something in place which can collect my data, because the rate of production and rate of consumption won't be matched like maximum number of the time. So you should be having some mechanism in place which can hold your data for some time and your consumer can consume it. So that's why we need some kind of queuing mechanism or message queues in between. And in the big data world or even in any real-time data applications, Apache Kafka is something which is really, really popular as the messaging queues. Okay, so now talking about the second last thing, which is the dashboarding tools. So the dashboarding is something which is not a mandatory skill set for the data engineers, but it is always good to have, because sometimes what will happen, let's say you completed your pipeline and you ended up with the transform data. So you need to also analyze it, right? Whatever your end users asked for it, you are populating the same thing or not, and that's how you need to visualize it as well. So that's why the understanding of dashboarding tools is also very much important. And there are three major important you can say dashboarding tools which are really, really popular, but there are multiple and many other dashboarding tools available, but I'll talk about the three. So first is the Tableau, second is the Power BI, and third is the ClickView or ClickSense, you can say. So these are the top three popular dashboarding tools, and like it is always a good to have understanding related to it. Okay, so the last and very, very much important skill set to become a good data engineer as well, that is understanding of the cloud platforms. So we all know, right? Companies are shifting from on-premises things to the cloud, right? They are operating their things on the cloud, and we have three major players in the cloud technologies. First is AWS, second is Azure, third is GCP. So all are providing services related to big data, and we can use those cloud platforms to create cloud agnostic data pipelines without even using any on-premises thing, right? So that's why if you are having a good understanding of any of the cloud platform, that would be really, really great. And again, from the freshers perspective, I'm not saying that it is a mandatory skill, but it will be definitely a good to have a skill set, and your profile will stand out from the crowd. Because let's say you have covered some specific cloud platform, for an example AWS, and you know all important services which are being used for the data pipeline creation. So companies will definitely prioritize your profile and you will get interviewed for sure. And cloud is definitely the future and you need to focus on it. And let's say you start with any of the cloud platform, so make sure you are not just working on the theoretical aspect or you are trying to understand it with the theories. Try to do some practical work as well, because these companies provide some free accounts and free services as well, which you can use and play around it. So that's what I had for you guys in this video, and I'm pretty sure this extensive roadmap will be really, really helpful for everyone, including the fresh college grads, entry-level freshers, mid-level, senior experienced guys. That is something which will be really helpful if you are moving into the data engineering or you are even trying to do the career switches. So you can follow this roadmap, but still you have any doubt, any question or any confusion related to the tools, tech stack, frameworks, or any confusion related to data engineering roles and responsibilities, feel free to put it in the comment section. And for more such videos, subscribe to Scaler.